Please do.
It works, yes. We think.
Sorry. So I'd like to welcome Thanos Koliopoulos, thank you, from Lloyd's. He's a Global Special Projects Manager for Lloyd's Register. He is currently responsible for the novel technology valuation and class safety case projects within Lloyd's Register's group. He has more than 20 years risk management and engineering experience in oil and gas, including LNG ships, FSRU installation, LNG LPG plants and marine terminals. His experience is supported by consultancies on novel marine safety aspects, including the technology qualifications of the first LNG ship reliquefaction system, the first safety case on gas fuel propulsion, the first combined oil cargo LPG vessel, and the first commercial LNG regasification with ship-to-ship LNG transfer. His current project involvement includes risk assessments, technology qualifications for LNG fuel propulsion systems, and LNG bunkering operations for major Asian and North European ports. He is a member of the SIGTO group for the LNG STS transfer and the CEN-TC82 working group for the development of the European standards related to LNG operations. So please welcome Mr. Thanos.
Thank you very much. Thank you. Is this working? Is it on? Just press the read only, and okay, and we go from down there.
All yours.
Lovely. Okay. Thanks very much for having me. Close subject to my heart, and given the opportunity actually to present it to you, it's LNG ship-to-ship cargo transfer. It's an area which is extremely overexpanding. I'm going to go through some of the technical aspects, but a lot of operations and safety is involved as well. So please make your questions, and I'll be happy to participate in the discussions as well. So we'll discuss about a general global operations, as happens nowadays, regarding LNG ship-to-ship cargo transfer. We'll then look at the critical equipment and operations that take place around the world. And then I will finish what I call World First, which is literally a rundown of the technology aspect progress and operational progress that have actually evolved, allowing gas to become potentially the major element in fuel worldwide. What do we have? Three typical operations happen worldwide nowadays. The first one is what it involves lots of cargo. Floating LNG, the Shell Prelude will come to the market very soon. And here I've got GPS, which is a concrete gravity-based platform. There is one in the world, Adriatico, in the Adriatic Sea, and actually offloads quite a lot of LNG daily. The regulatory issues and aspects that they include, and I'm coming inside so I can keep you all waking up. It's very simple. When you're actually offshore, class applies, flag applies, and the regulatory legal regime of the country of operation applies. If we now move to lightering, you probably have quite a lot of lightering LNGs taking place every day now. Well, it's once a week in reality. Ports are complaining because it seems to be a bit unregulated and very close to port waters. Why lightering of LNG? For the last 5 years, we have the impact of very large ships, Q-Maxes and Q-Flexes into the market. Most of those, they cannot go in certain ports or they cannot go into estuaries. On the other hand, we have two activities. Regasification requires a lot of LNG, and we have also the bunkering activities. That's where the lightering takes place, and it's quite a lot of this nowadays. Class, flag requirements, and when I said earlier on, Coast Guard requirements play a very important role to what I'm allowed to do and not to do. Last but not least, something which is really made the evolution of the ship-to-ship LNG transfer, and that's regasification activities and bunkering. This happens in terminals, in estuaries, majority of it, supporting power operations near shore, or supporting literally upgrading the gas output into a city grid in certain parts of the world. Operations that they are not only now related to the class flag activities, but they're very much related to port authority allowances because they happen in ports. Let's make a link a commercial link between the types of people and the types of ships and the output I want. In reality, if I want to have a regasification vessel installed, I can't do it if I require an output less than 500 million scf a day, which is related to something about 80,000 cubic meters a day. It doesn't pay out. If I've got a FSO, a floating storage unit, again, an LNG, it's a useful item to have in certain, especially large bunkering ports. I can't do anything if I'm not prepared to use about 1 billion scf a day. And then we move into the really big beast, which is the FLNG. 3 years ago, pointless to have an FLNG if you're looking to not to be able to export 1.5 with the prices of gas at the time, and that's about million tons per annum. Today, I would say you're looking at 2 to 3 minimum. 3.2 million tons per annum is what Prelude exports. Then we have the mother carrier to lightering operations, and last here I put bunkering because bunkering evolves continuously. Currently, small coastal ferries, 400 cubic meters, 600 cubic meters, but we now have vessels involved to 1,000 cubic meters, with a combination floating crane that you see later on to 8,000 cubic meters, now actually in construction. And just a bit of a round back, I used this photograph of the FSRU to show you how much safety is related typically to ship operations. So in addition to a normal LNG carrier safety, which if you add a regasification system forward, here you would see that it's quite substantial. Then you have berthing loads to address, cryogenic impact to address, vapor return to address, emergency disconnection system to address. Quite substantial. Very quickly from the equipment point of view, about 9 years ago, the first full cargo ship-to-ship transfer took place, and took place with hoses. Hoses was nothing new in the LNG LPG industry. We used to have them on the ships in order to actually address emergencies. But this hose that you see here, the Guttering hose typical, that's a good example, it's an evolution of that design. We're using 8-inch hoses. They're about 25 layers of material supported by a spiral metal construction. They're very flexible, they're light. Why 8 inches? So we can couple them to the 16-inch manifold, standard LNG ship manifolds to operate. So when we export, when you see the next photograph below here, we export with 3 manifolds on liquid and 1 manifold of vapor return. The hoses are certified, and the hoses are also designed according to design standard performance, which is based on a European standard 4074. However, that is if you're looking to export something like 6,000 cubic meters per hour in liquid transfer. If you're really looking to have far, far greater volumes, you can't do it with hoses. You need literally a fixed arm, very typical to what you have to the LNG terminals. Now, when I was starting with hoses, the big boys in this area, the FMCs of this world, they went to IMO and they made a notion about it. Why we're allowing ships to actually transfer with hoses without having an appropriate PERC system, emergency release system, as the arms requirement is for terminals. And the industry at the time, we were defenseless, simply because, it's not because we did not want the system to have it on board, there wasn't any. None has been designed. Nowadays there is one, you'll see it later on. But this particular design, which is used on the Prelude, is so much also simplified and made marinized for marine application. It's a lighter arm, and the most important of this arm, because of the difference in thrust between the huge Prelude and obviously and the coming LNG carriers to float, it can operate 10 to 15 meters radius below the main deck, which makes operations really important for the various drafts. This type of arm is very much designed outside the ship envelope. It's designed for something 25 years of continuous life, fatigue life, without actually dry docking, without changing. So So something actually to think when you're looking about offshore operations. I talked about safe and isolation control, and that's the system that you see here. I don't know why my pointer is not working, but the system that you see here on the top picture is actually the emergency release on the hoses. It is specifically designed to operate for hoses. The two ships, however, they have to be able to initiate two isolation modes. ESD1, which is basically stop your cargo, and ESD2, which is actually release. And the two modes, in order to address marine motions and operations, they are linked. So there is a pneumatic or electrical link between the two ships, which if it's actually going to be interrupted, then might go to the ESD1 mode. If now the operations of the ships are wide enough, then I initiate manually or automatically separation of the systems. A little bit of the critical equipment, saddles, you use them obviously for the oil cargo. Here a little bit different because what I want to do, two things. First of all, I want to avoid the kicking of hoses and line them up to the manifolds. Second, which is the clever mechanism behind it, I tie the top of the hose, so when the ERC separation takes place, the hose doesn't drop, doesn't create any impact on the side cell for ignition sort of sources. It drops very, very slowly until it separates. Again, the manifold issue, how to address it? I address it with spools, specifically designed. Very important issue, which I've forgotten to actually ask the question, but you've got to understand is the compatibility between two ships. We never go to do LNG C2C transfer without having pre-compatibility checks, which they take early into the operation phase. So the contract does not place with the charterer unless compatibility checks have actually been taking place. And when they actually get checked, and we know that we can line manifold, we know that the systems are compatible, then the contract is taking place. So that's something very important to understand. As in terminals, here in ships, we have continuous water curtain on the side of the vessel to protect it from potential cryogenic impact. And it's a nice way to do it because now the mothership, this is the FSRU in our case, has the ability to provide a portable system to the LNG ship to protect the side of that ship as well. I've spoken a lot about obviously cargo transfer, but it's very important to understand is a lot of investment and a lot of technology actually input is going now to evaluate system for bunkering operations. Not so much the coastal water bunkering, but the deep water bunkering which inevitably will arrive. These systems are very much lightweight. They will use combination of hoses, 10-inch hose, 6-inch hose, which seems to be the preferable size currently, but with an articulated arm or supported by a crane. I put the top drawing there to show you something else. This is a design we're currently certified for the Port of Singapore. This is literally an offshore floating platform that they will operate in addition to the normal bunkering facility in Singapore to enable larger ships to come on and get bunkered with quite a lot of LNG as fuel. We discussed about hoses, we discussed about vapor return, and the port mentioned the environmental issue. In LNG, it's not the environmental issue only. That's the least of our worry. In LNG, I have to have vapor return. There is no any other way around to operate the integrity of my storage system. So, one, when I'm receiving liquid from another vessel, I'm throwing it in a relatively more warmer tank. Even 2 or 3 degrees down from 163 makes a difference. I use a lot of actually energy in these lines, friction, pumps, so the difference in temperature is substantial. That produces a lot of vapor. The ship cannot operate under these pressure conditions. We have to open valves in port. This is totally not allowed. And also the integrity of the storage system cannot be operated. To give you an idea how important it is to have vapor return to the given ship, on how important it is to use other systems, either liquefaction or use the boilers. When I'm actually exporting about 6,000 to 8,000 cubic meters an hour, if my pressure get up by about 2 bar, I have to drop 1,000 cubic meters at 2 bar pressure. You can imagine how much elongated this action of ship-to-ship becomes. maneuverability. Very important for a variety of reasons. Some of my colleagues earlier on touched into the crew performance, the piloting performance. But for LNG, there are other important issues, many of them legal issues. Let me give an example. The LNG ships got high windage area from most of the other ships that are around. It means that if I'm an estuary, or if I'm in critical turning corner, under high winds, I have to go higher speed. If I go lower, I've got a serious problem of grounding. Now, some ports, some administrations, some governments, some of these facilities, they have been regulated for very low speeds. So immediately, I need real-time maneuverability simulation analysis to show to these bodies how it's going to be done safer. Okay? Because otherwise, you cannot show them by words or by any other risk assessment is not visible. So I'm using actually this to map the whole passage of the ship, including the arrival of that ship at the port, including the requirements, which is very important for the port authority. It's very important also for the commercial users for the port authority. You raise the requirements of the number of tanks for these type of operations that we need to do the safe maneuver. And we play it according to actually having n-1 number of tanks. During the maneuver, we take the one of the critical tag out to see how the maneuver is actually safe or not. Last, but very important and very different when it comes here to an LNG membrane tanker, I have the issue of lossing. LNG ships, like any other cargo vessel, is designed to be either 95% full or more, so laden, or at ballast, 10% and less. Now, in this intermediate stage, when I have, because of ship-to-ship operations, various levels of liquid within the tanks, under certain conditions of wind, rolling, angle, have a serious problem of loss. Serious integrity issue now for the containers of the ship. So all our operations, especially the near-shore operations, where we're exposed in the environment, require risk assessment in order to address, first of all, the sloshing issues within the tank, and then the local environment, and most important, the ability for that vessel to stay safe within the sloshing range for a certain time, in order to make it possible to either take off and go to a safe anchorage, or operate the loading in such a way so I can eliminate this space as quickly as possible. Okay? There's a lot of risk assessment work that it goes to the ship-to-ship LNG operations. Sometimes I don't address them directly because most of the people who are in the LNG industry are fully aware of it. But let me give you here an example of the risk assessment work that actually took place to make reality the first full cargo offshore between two ships. The ships were 138,000 cubic meters DSME made. You can see that we started with a failure mode and a first analysis of the offloading system. We've gone to a RAM study for the critical spares that even before the ships were actually even considered to do the operation. Then we've done to a numerous of hazards of the ship-to-ship transfer system. We've gone to dry HAZOPs with a number of spools to find out what's best. And then we go obviously to wet HAZOPs with very small volumes to see what's going to go wrong or not. And then we start thinking of the legal issues, to do the environmental impact assessment, to do the deep water application to the American port, to see how this will apply. It is not a straightforward sort of work. It takes time, it takes experience, which actually would build it up with working close with the operator. And as I said before, I was fortunate, we see the photograph earlier on, to be on top of the full cargo transfer could take place in the Scapa flow in Scotland. Why? Because it's very benign, that's why, at the time. So, just a critical overview. A lot of issues regarding ship-to-ship operations will have to be addressed. Of course, traffic, piloting issues, port authority issues. Then the type of operations that take place between the two manifolds. Compatibility is an absolute must. Emergency disconnection, control, isolation means, all of these things have to be examined. They have to be HAZOPed. And then we have obviously the actual operations, the partial fill of the operations. Again, if you're wondering, what happens to the FSRU or what happens to the LNGC, which operates full-time with partial tanks? Not an issue. They have been designed, their tanks have been actually strengthened for this type of operations. It is the normal LNG carriers here that they have the issue, that they would come as charterers to do this operation. Okay. And then obviously we finish with very important issues, the emergency response and the third party impact, because this is also part of the insurers and the legal requirements of the country of operation. All this takes place with risk identification techniques. Okay, I'm going a bit fast, but we don't have to use our coffee time. Yes, of course. So that's the last one, nothing to worry about. But it's important to look at the track record. In order to reach the first FLNG, we started something like 10 years ago. And if you look, the first ship-to-ship, it's the Boston Neptune. Then we go further travel, the first ship-to-ship full cargo in Scotland. Then the first regasification at port terminal in Teesside. The first terminal with ship-to-ship on actually hard pipe in tandem is still operating, Min Al Amani in Kuwait. The first terminal with ship-to-ship operations, again over hard pipe across each other. It's in Guanabara, still in operation. And then we're moving actually to look at larger FSRUs. VT3 here, it's Exmar Accelerated Energy, 171,000 cubic meter. And then to the two terminals to be lately certified and fully operating in South America, Escobar, Bahia Blanca. Escobar last year, 53 full cargo ship-to-ship operations. It's going on every year, getting more. They are trying to redesign the actual facility currently to accommodate more vessels. And then obviously would Shell Prelude would, if all goes well, and if Shell still thinks that they can make money, should go in operation. Well, still Shell would, because it's a self-financed project. The project value, ladies and gentlemen, are about $5.5 billion. Two FLNGs, they would cost around $12 billion. And may I remind you that the work for the first FLNG has started with Lloyd's Register about 10 years prior to the contract report. So the marine studies, the marine classification studies, structural analysis studies, they've started about 10 years prior to this work taking place. And the project was self-financed. So I think they will make money at the end of the day. Last, things to come. I put the Herema offshore lift crane, I think it's the second biggest crane in the world currently. And what you see there, it's in the inside legs, both sides. It has 8 vertical LNG tanks, 1,000 cubic meter each. This vessel is in construction in Singapore and intends to maintain position on LNG fuel at near shore locations during the operations. Obviously, we have the two big Panamax vessels there, the Viking vessel and the Vancouver, I don't remember the name of that vessel now, two of those that they are actually going operation. And a variety of other designs, including the first, I think you've done some work and other people have done some work actually on the first container ships, given the due to our classification societies here. No problem with this. So there is a lot of things to come. And most important, none of them will operate without safe and integrity in ship-to-ship operations. Thank you very much.
Very, very lively presentation. Do we have time for questions? 5 minutes?
Yeah.
So 5 minutes from the floor, if we can, please. Someone maybe from middle or this side.
I was less a question, I was more interested to hear your perspective, sort of the Rotterdam perspective on this, obviously a major port.
Oh. Well, it's quite simple. A few of those pictures you've seen in this presentation were from inland barges already bunkering in the port of Rotterdam. So, but it's coming from truck to ship, still truck to ship. We will have in 2017, early 2017, a seagoing bunker vessel from Shell in the port. We are now working on studies for bunkering cruise, working on tugboats on LNG. We will have the first ship-to-ship bunkering in the port of Rotterdam with LNG, coming from the LNG Shell bunker vessel in also first 2017. So we have already the suppliers, we will have the consumers of the LNG, and it starts. It's not going that fast as we thought it was due to the low oil price, but it will be there. And we got the regulations in place. Inland regulations are most in place. Some of them are approved but not yet enforced yet. And the seagoing regulations, well, we got the ISO standards now. One of them still in concept. We got the IGF code, and so also the regulatory framework is in place. So, well, when it is feasible, when you can have profit of it by sailing on LNG, and when you not change over to scrubbers, I think you can do it, and you can do it in Rotterdam as well as in some other ports.
That's another part of presentation, which maybe we'll do it another time. But it's hugely involving a lot of ports. So we're talking here that from the operational point of view, looking at operation manuals, looking at operation procedures, putting facilities in place. Majority of 25 ports currently in full actually operation, leading by Singapore.
25 worldwide.
Worldwide.
Yeah.
Alex.
Quick question. Mr. Koliopoulos, you mentioned an extensive risk assessment that has to take place prior to its operation. Is this risk assessment conducted by the owners or by third parties?
The risk assessment always conducted by independent parties. Whether that party could be a party like Lloyd's Register as an example, a classification society, or another independent party, it's usually conducted by independent party. Now, the issue who conducts, it's one issue. Who pays for it is another issue. So we have to make that clear. Usually, in the operations that you actually looked, it's the operating company or the owners of the terminal, not the ship, which is the charter in that particular, that they've paid quite a lot of money. But if you look, however, in accelerate and export sort of operations, we've got the export company here, we can discuss that they have taken place worldwide in order to provide the vessel with the right ability and the right system to undertake this operation worldwide. Everything has been paid by them. So what you find in the LNG market, because that's the way people operate, you don't go empty-handed somewhere to say, I'm good because I've got a large ship. This is not good enough. You have to say, I'm good, I have a large ship, there is all the documentation of my system to be actually put operation, there is all my risk assessment of how I best do these operations with my equipment, and there is the operation manual that you have to comply with, because otherwise I don't want to get involved in these operations. And this is where my big question mark to the port was, and still is, not to you as your personal port, to ports in general. Currently, in the bunkering sort of market, what we have is very competent oil operations. Oil bunkering and oil storage has nothing to do with LNG and LPG in operating matters. Totally different type of operations. Totally different risks, totally different operability. These sort of third parties, currently, they are all lined up to provide LNG bunkering or LNG ship-to-ship services, whether it's for bunkering or for any other purposes related to bunkering in ports. So the very important issue here is ports should take hold of this situation and make sure that they will provide the standards for these people to qualify first in order even to compete for this service. This is how it should be done. Because otherwise, I'm open to an open competitive area for people who they have something to do with LNG by name only, not by operation.
Port of Rotterdam, the LNG bunker companies are accredited. There we got quality and safety rules.
Yeah, but accredited on what? That's my issue. Are you accredited on a typical operating criteria, operating performance requirement, checklists that they are based on SICTO or ISO standards? Not talking, nothing to do with it, I'm sorry. On what? And it's not a question to you. You know, it's a question that, and the industry has actually understood the question. Singapore, Vancouver, Piraeus, they're currently putting together operating LNG ship-to-ship procedures, not because they want to operate the ships on their own, nothing for it. They want to create strict standards to know who will come in and actually compete for this service, who will actually provide a service, because it's a legal aspect here that you have said, well, there you are, I have standards, my standards have actually put together with other vessels, known operators, classification societies, third parties, with risk assessment and everything. And it's really, as everyone will tell you, every captain will tell you, as any competent manager will tell you, it's a matter of checklists. I'm sorry, but at the end, the most complex operation becomes a very correct step-by-step process followed by some crew who has to have qualification, and that's the other problem. The crews that they, on the LNG ships, fully qualified, best paid crews in the world, let's not forget that, best paid crews in the world, but on the other vessels, nothing currently.
Can we save that question for later? It's just very much running out of time. Okay.
Hi, I'm George from DYNAMARINE. Very nice presentation. I just wanted to ask you, what compatibility issues could someone face for the LNGs that is different than the tanker ships?
A lot. Starting first of all with the size of vessels in order to have compatibility for the manifold lineup. Then, most important aspect is the aspects of vapor management. How do you manage vapor? Okay, it's a lot. I can give you an example right away. Okay, this is maybe to help people understand. We try to do ship-to-ship LNG transfer with Qatar Gas Q-Max ship and accelerate Exmar energy ship. We couldn't do it. Why? Because on the vapor return back from receiving liquid from the Q-Max, the Q-Max would not accept to use GCU, would not accept to burn some of the extra gas, and the reliquefaction system which the Q-Max has. So they can take the vapor, reliquefy it, will not operate because the temperature of the gas was actually warmer than when the system was designed. I'm sorry, I'm getting a little bit too intense, maybe technically, but there are serious technical issues. So it will never happen. Q-Maxes cannot do that, Karen.
Right, can we call it at the moment?
Thank you very much.
Oh, you're welcome.
Just remember, we do hopefully have an hour break for lunch. Not now, then you can follow up further conversations with Thanos. Can we please try to come back at 12:05? And it's been a very good conversation. Thank you very much.